The broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, everybody, and welcome along to DBA Fundamentals for the month of November. My name's Warwick Rudd, and once again, I'm hosting you for this session. For today's session, we've got David Alzamendi talking to us about relational databases in Azure. I will hand over to David very shortly, but before I do have some housekeeping to run through for everybody. First of all, this session is being recorded and will be available on the DBA Fundamentals archive site in a couple of days' time once the session's finished and the recording is all processed. Feel free to put your hand up or ask any questions. There is the questions tab, and I will be monitoring those questions throughout today's session, and I'll ask those questions to David at the end of the session. Now, we wouldn't be able to put on these sessions without our sponsors, so our first call out is to SentryOne as our first sponsor. If you haven't already gone to their website, make sure you do. They have some fantastic downloads and free materials available for you to assist you along your learnings and in your day-to-day work life as a data professional. Our second sponsor, DBWatch, just like SentryOne, has some fantastic downloads and free material also available that can assist you in your day-to-day activities and learnings as a data professional. Just like this virtual group, there are many other virtual chapters available for you to join. If you haven't already joined any of the others, make sure you go to the PASS website, have a look at the virtual chapters, and choose the appropriate chapter that is of interest to you. Register and you'll get notifications just like this session on the upcoming sessions that you're able to learn and continue learning on all things data platform. So with that, I will hand over to David and we'll get today's session rolling. Why is this not handing over?
Maybe, hey, Warwick, thanks, man, for introduction. Maybe if you try to stop sharing.
You should be able to, there we go, it's all right. There we go.
There you go, the live. Awesome, thanks, Warwick. Thanks a lot for the introduction and for leading this community initiative, actually, and contributing to it. Okay, guys, welcome to the virtual chapter, to the DBA Fundamentals. Today, we're going to be looking actually at relational databases within Azure. I am David Alzamendi. I'm your speaker for today's session, and I work as data architect at Worthy IT Solutions, pretty much focused on the business intelligence and data analytics solutions. If you have any questions, please feel free to reach me in the social networks. Don't forget to get involved, even despite COVID-19. I think it's really good for the community if you can get involved with the virtual chapters or local user groups, or even within your company, trying to share your knowledge and even presenting a session. The agenda for today actually is to go through an introduction and understand a little bit more about relational databases and how they are different from non-relational databases, and then we'll go pretty much and we'll look at the Azure offering for relational databases. Our objective for this session will be to understand the key differences between relational databases in Azure, understand database computing architectures, specifically SMP and MPP architecture, understand as well the services and tiers and purchasing models that you can take advantage of within the Azure environment. As we go, we'll run a few demos. So let's kick off relational databases. So I think we need to understand what relational databases are, and we need to be able to compare relational databases with non-relational databases. Therefore, actually, we're going to start with the definition of non-relational databases. In non-relational database, pretty much the schema is quite flexible. You can easily scale out compute power and through different nodes. And you can also store non-structured data, right? So when you think about non-relational databases, you can think about MongoDB, DocumentDB, Cassandra. There are many databases out there, or even Cosmos DB, if I didn't mention it. There are many non-relational databases that can help you to scale out your applications. So when you store information within non-relational databases, you pretty much you don't need to define data types. The schema for your data assets is going to be quite flexible. Therefore, you don't really need to define, for example, that you have a table that has 20 columns and each column has a data type. That doesn't happen with non-relational databases. Now, for today, relational databases is the main focus. Relational databases are usually represented in a tabular representation. So you have tables and columns. Then each table is going to contain rows, tuples, and then you'll assign the schema when you write the information within the tables. That means that when you insert the record within the table, you're already assigning a specific number of rows. Each column has a data type, and the schema pretty much is being defined at the point when you insert the data into the table. And most of the relational databases, if not, most of them, they offer like some sort of SQL language to query the information, right? Even when you think about relational databases, I would suggest to go and have a look at DB Engine's ranking, and they do give you a really good idea on which ones are relational and non-relational databases. You can see that at the top of the list, we have all of them are pretty much relational databases. For today, we're going to focus in a specific cloud model. So as you know, we have there are different cloud models. These are only 3 examples: the infrastructure as a service, platform as a service, and software as a service. The main benefit within the platform as a service offering, and is the one that we're going to be covering today, and all the services that are going to be running in this cloud model, is that you only need to look after your applications and data. Everything else is going to be managed pretty much by Microsoft. So we don't need to be worried about servers, storage, networking, virtualization, OS, patching, anything. We don't need to look at anything of those things. Everything is going to be managed by Azure for us. So we can focus on delivering solutions and looking after the application side and data. When you think about relational databases within Azure, so we have, of course, we don't only have one option, we have many options. You have those ones that they come with a SQL Server engine, and those ones that they come from an open source methodology. So with the SQL Server engine, you can think about Azure SQL DB, Elastic Pools, SQL Managed Instance, or Azure Synapse Analytics SQL Pool. And then within the open source offering, you can find MariaDB, Postgre, or MySQL. What is important here, and we're going to cover it today, that I have highlighted here the compute engine that we are using in each one of the offerings. You can see that these 3 options over here, they're using the symmetric multiprocessor system, as well as the open source databases, but it'll be different actually for Azure Synapse Analytics SQL Pool. All of them, there are platform as a service products, and you get pretty much 4 nines of availability. That means that it'll be only up to 52 minutes of downtime a year. And you can also mitigate that by using pretty much replication across different databases if needed, or plan for high availability scenarios within these products. I would say I used to work a lot with clients who are migrating to Azure, and I wanted to share a few key questions that I'd like to answer to identify the database that is going to be a good fit for my clients. What's the business goal, right? So what are they trying to achieve with this migration to Azure, or what they are looking for? Are they trying to build an application? Are they trying to build a data warehouse, a data mart, a configuration database? What's the business goal overall? So you can understand what they're trying to achieve. And then you come with more maybe technical questions, right? Not technical exactly, but you want to know, okay, is there any budget that we need to think of when we are going to allocate this Azure database? Do you need one database, or you need many databases? Is it a greenfield environment? Is something that we're building new? Are we going to migrate from on-premises to Azure? What is the size of the database, right? So you need to plan. If it's a greenfield environment, so you need to understand actually how big the database is going to be. If it's a migration, you already have a lot of information there, so you are able to take advantage of the existing size of the databases to understand how much storage you're going to need within Azure. Then, are these databases going to be transactional, or they're going to be used for analytics? Like it'd be extremely different if you're planning for an application database than if you're planning for a data analytics database, like a data warehouse, data mart. And finally, a few more that you need to be aware of. If specifically with analytic database, doesn't need to be available 24/7, or they're going to be running reports or querying the database only during business hours. Are they going to access the database, or are they going to access the reporting layer? Maybe they have all the reports available using Power BI import mode, and your database therefore doesn't need to be available 24/7. So you need to factor for this when you capture the information. And then a little bit of planning, right? How much is going to grow that database during the next few years? And even from a strategy point of view, right? You may decide today that you want to go with a specific product. You need to think if that product is going to fit for purpose in 1 year and 3 years. Do a little bit of planning. So those are some key questions that I'd like to ask my clients when I start any project that requires a database, and of course cover DR as well. Let's upfront answer a little bit that people they usually want to know about this pricing. So actually, when you think about any relational database within Azure, it's really difficult to compare apples with apples. Okay, but at a really high level, if you were going to classify these services, taking into account the starting tier, okay, this would be the starting tier for each one of the relational databases in Azure. You can see that the single database, the starting tier, will be only around $7. This price is pretty much, if I quite remember, this is Australian dollars. And then you can see how Azure Synapse Analytics, SQL Pool, and Managed Instance, they'll be in the less cost-effective side, while those open source and the single database will be in the most cost-effective sides. We're not comparing apples with apples, but I'll give you a good understanding on how what the starting price will be for each one of the products. Within the SQL Server Engine databases, we can say that we have 4 main products, and those products are pretty much Azure SQL DB, and it's being offered within the Elastic Pools and SQL Managed Instance, and then you have Azure Synapse Analytics. Today we're going to break down the information for each one of them. Within the Azure SQL DB, pretty much Elastic Pools is built on top of a single Azure SQL DB managed instance, pretty much the same, as well as the compute nodes within Synapse Analytics. All of them, they are using a symmetric multiprocessor system. And what this means, actually, from a computing engine point of view, is that each one of your CPUs are going to be sharing the storage and the memory when you send some workload. Imagine that you are querying information within a database. So within this architecture, all the CPUs are going to be sharing the memory and the storage. Think about your laptop. That's a good example. Your laptop as well may have 4 CPUs, and you have 16 gigabytes of memory and 200 gigabytes of storage. What is going to happen is that those CPUs are going to be sharing that memory and storage while performing any type of workload. The purchasing model for the Azure SQL DBs comes in different flavors. You have the database transaction units, DTUs, for Azure SQL DBs. Then you have the Elastic Database Transaction Units for the Elastic Pools, and then there is an offering as well for vCores. This is what DTUs and Elastic DTUs are. It's pretty much a combination of memory, CPU, and bandwidth, while in the vCore side, you have more control actually on the resources that you are assigning. Also, to understand that when they first released the Azure SQL DB, it came with the DTUs option, database units, for a basic, standard, and premium service tier. Only a few years after, when people were asking to have more control, understand which hardware they were allocating to each one of those tiers and how many cores they were allocating to those service tiers, they released the second generation that is pretty much general purpose, business critical, hyperscale, and serverless. But to summarize, what we have here is that the first generation pretty much works with database units and Elastic database units, and the second generation is pretty much based on vCores. Within the service tiers, of course, you get different SLAs, you'll get different hardware in the backend, your IOPS will be different as well, and the maximum storage size per database is going to change. Here you can see how we have either way, first generation or second generation, how the SLA is the same, pretty much the same for all of them, but serverless. And then the retention period for the backups is going to change between the most cost-effective option and the other ones. The CPU will be that you get will be different, as well as the IOPS. Some of them they don't support column store indexing. Some of them pretty much different. They have different maximum storage size per database. If you were going to go with the most cost-effective option, you need to understand that there is a maximum size within the storage that you need to factor in. And then, as I mentioned before, so all the basic standards and premium of first generation, they come with database units and Elastic database units. They are not available in SQL Managed Instance. I think the reason for that is that SQL Managed Instance got released after they released the second generation of purchase models. And you can see that general purpose, business critical, hyperscale, and serverless, pretty much, these ones, they come in a vCores option. At the bottom as well, I added serverless means pay per use. So it means that if you execute a query, you're going to be billed only for the execution time of that query, while in a offering that is not serverless, pretty much what you're going to happen, you're going to allocate, for example, 4 vCores, and at the end of the month, you're going to pay for those 4 vCores, so for the pre-allocated resources that you have selected. So serverless, the whole idea is pay per execution time of your queries. And we're going to see that actually that is available within a single Azure SQL Database, and is available as well in Azure Synapse Analytics in the new experience. Within Azure SQL Database, as I mentioned, you have 3 different deployment options. You can deploy a single database, you can deploy a managed instance, or elastic pools. So what we've seen within the Azure SQL Database is that all of them are based with the SQL Server engine, but this one, if you were going to start doing something with a single Azure SQL DB, you only need one Azure SQL DB, one database with enterprise capabilities. They'll be a good fit for you. It's offered either with DTUs or vCores. Everybody knows SQL, but some limitations come down to cross-database queries are not allowed, and you won't have the SQL Server agent jobs. What you get pretty much is just a single managed database within Azure. That's what they call a database as a service. And if we jump into the portal, actually, I go to the Azure portal. So here you can see that if we were going to create a new resource, one of the options that we have in databases pretty much will be this one, the one that we're talking about. So you're going to create a single database. The other thing that we need to take into account here, you can specify how, if it's going to be elastic pools or not, and this is what we covered before. So that service tier, pretty much we can reduce this to be the most cost-effective option. So we go for basic, standard, premium, and we select basic. And you can see that this will be only $7 Australian, excluding GST per month. Another thing that I'd like you to understand is that this database is going to be hosted in a logical server. So when you create this database, you need to specify a logical server where you want to store the database. And also you'll select, when you create this server, you'll select the region. That's quite important for us to understand where our data is going to be located. Another point is that within a single logical server, you'll be able to have different database offerings. So right now in Management Studio, you can see that I have a logical server and I have a single databases and an Azure Synapse Analytics over here. That's going to reduce the amount of database work, administration and configuration and security you need to look after. That'll be a single Azure SQL DB. Now, then you could go with elastic pools. So elastic pools, pretty much what you'll do is to allocate a specific number of resources. Let's say that you allocate 4 cores and 500 gigabytes of storage, and then you'll be able to create as many databases within that elastic pool as you want. Main benefits, this is built for unpredictable patterns or applications where it's difficult for you to identify the resources that you're going to be using, but you do need multiple database instances. And you are allowed, besides that, you're not allowed to have SQL Server agent jobs. Now with elastic pools, you'll be able to perform elastic queries. So pretty much to execute a query across multiple databases. Of course, you're allowed to create as many databases as you want. There are some limitations, but they are really high. The price is going to increase. So when you look at the elastic pools, so the price of the database units will be 1.5 the price of a common database unit within the single database. So if you were going to create, again, elastic pool, so we use the same example over here, So we can define this, that this is an elastic pool, and you can create a new elastic pool and define the storage that you want. Once that you define the storage, and you say, okay, I need 4 vCores, and for example, let's create one here. You can define how many resources you need within the elastic pool, so you're going to be allowed to create as many databases as you want. That's a really cool idea. When do you want to use these elastic pools? So for example, I mentioned before, imagine that you create elastic pools and you only have one database. What's going to happen right now is that you're going to be wasting a lot of resources. And you're going to be, of course, going to be paying for those resources. So if you're planning only for one database, you know that elastic pools maybe is not the way to go. But now imagine that you are planning for 5 databases, or 4 databases in this case, right? You see that we're able to take advantage of those resources better, right? So we have more spikes, but we still have these gaps over here where we're not fully taking advantage of those resources. So you're going to be billed for resources that you are not actually using. As the number of databases that you need for your applications increases, you see more value on this service. Potentially, you could have one elastic pools created and create 20 databases that pretty much the price will be the same, and you'll be taking advantage of those resources. Now, the thing that you need to take into account here, when an application, if you don't control how many resources you allocate per database, so you may have one database that is affecting the performance of other databases. Then I'll give you a good example. So I've created previously elastic pools, and I have this PowerShell script here. So pretty much what this script does is pretty much create databases using elastic pools. So if I wanted to know more about my elastic pool, so I'll come here, I go to the Azure portal, and there is a specific section actually for elastic pools on the left side. So if I click here, you'll see that I have previously allocated these elastic pools resources. In the lowest tier, this is around $130 Australian dollars a month. But with this script, you see here we only have a few databases. With this script, you'll see if I run, what it'll do is only to create databases using that elastic pool resources. So you can create, for example, up to 100 databases and see what happens. And this script is going to run for a few minutes. But what I'm printing here, pretty much, you see that as we create more databases, the price per database is going to decrease. And that's the whole idea. The more databases you have in elastic pools, the most cost-effective the solution will be. So if I go over here and refresh, this is going to start creating databases. The whole idea of this script may take some time, but what we'll do is we'll open a new PowerShell script. And we're going to just to hide that one. So you see, as the number of databases increases, there you go. So you see that sprint this over here. You see how as the number of databases increases, the ongoing price for each one of them is going to increase. So at the beginning, I'll be paying around $111 for one database. If I have 2 databases, I'll be paying only $50 per database, and as the number goes up, potentially, if we have applications that they don't require a lot of resources, we could be talking about an enterprise database where the ongoing cost is going to be only $1.10. It'll be less than $1 if we're using the US price. And finally, you have SQL managed instances. This is pretty much like for like to the SQL services, SQL Server that you have on premises, the same as the SQL Server, pretty much the same as the SQL Server instance on premises. Because it's pretty much the same, so now you'll get pretty much SQL Server agent jobs. You'll be able to take advantage of pretty much all the features that you have in an on-premises SQL Server instance. So not only that, is that if you're going to migrate from on-premises to an Azure managed instance, is that Microsoft offers you a set of tools that you can take advantage of. And the migration is going to be pretty much really easy to execute. You just need to repoint your applications to the Azure SQL managed instance. And if you are working with aliases or DNS names, that will be really easy for you. There is a really useful application that is provided by Microsoft. It is free. If you're looking to migrate from SQL Server on-prem, an instance to an Azure SQL managed instance, pretty much you can use what they call the the data migration assistant. So this is a Windows client tool that you can use, download as well by using the Azure Migrate service in the portal. But this is a client tool that you can download and create a project just to assess if you can migrate the databases or the instance. For example, let's create a project. Let's call this project test migration. We want pretty much based on a database engine. I want to move from SQL Server. You can select even if you want to move a database to Azure SQL DB, or in our case, to a managed instance. So I can create. Then what we're going to achieve here is to get a report for database compatibility, as well as to check if the features that we're using on-prem, they'll be available in Azure SQL managed instance. So I click next. I get a server name over here. This is my on-premises database instance, sorry. This one with multiple databases. Now, pretty much click connect. We're going to run the assessment, maybe not in all of them because it will take a few minutes, but we choose Adventure Works, this configuration database over here, SDU tools, the one that Greg Lowe built, and this one, click add, and now we start the assessment. You can see that some of those compatibility levels, they come from a previous version of SQL Server. Some of them even they're quite old. So we start the assessment. And this is going to run an assessment on my local SQL Server instance and tell me if we're ready to migrate to Azure SQL Managed Instance. As you can see within the features, we're not using any features in SQL Server on-prem that are stopping us to move to Azure SQL Managed Instance. And then we can look at the compatibility report. And pretty much this will come up. If there are any compatibility issues, it's going to tell us that they cannot migrate maybe those databases to Azure. Once you finish the assessment, using the same client tool, you can also migrate the data, which is great. I highly recommend this tool if you are working with databases they don't go over 500 gigabytes of data or even over 200 gigabytes of data. So if you were going to migrate from SQL Server on-prem to Azure SQL Managed Instance or a single Azure SQL DB, and the database is not that big, definitely do the data migration using this tool. The data migration as well, something that you need to take into account, will take, you need to factor as well in if your network connectivity is really good, it's bad. So when you're doing the data migration, it relies heavily on the resources that you have in the destination database, how fast you can write the data in the destination database, but as well as how fast the information can go through the network. So those are considerations that you need to take into account when moving the data using the data migration assistant. Everything comes pretty much my suggestion will be for you and go and explore the migration tool, but you can also control all the migration steps using this service that is Azure Migrate. Okay. And you can see even within the script of the Elastic pools, pretty much, maybe we'll stop it. But you can see how we are creating databases using those Elastic pools. So just to cautious about time, so what I'll do, let me see if we finish the assessment. We'll go back to the presentation. This was pretty much what I wanted to cover related to the databases within the SQL Server engine that they use, the symmetric multiprocessor compute engine. Now we need to look at something that is built on top of a kind of SQL Server engine, but it's not the same, it's special. And we're talking about Azure Synapse Analytics, SQL pool. This is formerly known as Azure SQL Data Warehouse. It uses a different engine. If you were going to start using this product, taking into account only your existing knowledge on SQL Server engines, you may run into a few challenges and you have some pain points while using this product. So the better for us to do actually is to understand how the engine works so we can take advantage of it. So a massively parallel processing compute engine works differently. So here we're talking about distribution. We're trying to distribute the workload across different compute nodes. So imagine this architecture here. So in this architecture, in this example, we have one control node, different compute nodes, and the storage. First thing that for us to understand is that each compute node has its own memory. It has its own CPU. And it's going to be looking at a specific section within the storage. So that means that when we receive a query through the control node is going to distribute the workload for that query across different compute nodes. And each compute node is going to perform some work on a specific part of the storage. So it means that by distributing that workload across different compute nodes, the performance is going to increase a lot. Main difference with symmetric multiprocessor system, you've seen here, each compute node has its own memory, its own CPU, and is looking at a specific part within the storage. That's going to increase the performance. That's why it's so good for loading and working with terabytes of data. What it means as well is that you need to understand how to better distribute the information within the storage. The storage within Azure Synapse Analytics is distributed logically in 60 partitions. That could go up to 180 partitions, depending on how many compute nodes you have. But for most tiers within Synapse Analytics, your storage will be split across 60 different partitions. So that means that this compute node from here, so here in this example, we have 4 compute nodes. So each compute node is going to be looking at 15 partitions within those 60. So you need to plan how to distribute the data across those different 60 partitions. That will bring a whole different topic about heap tables, column store tables, distribution to be round robin or based on the specific, right? So just keep in mind that if you're starting with Azure Synapse Analytics, that the engine is different and you need to plan for distributing the information correctly across those different 60 partitions. Then within Azure Synapse Analytics, one of the key features when they released the product many years ago by then Azure SQL Data Warehouse, was that they decoupled storage from compute. So have you seen here before? So the compute is decoupled from the storage. So that means that you'll be able to grow storage or compute independently from what your business need is, right? Because if you only need more storage, you pretty much you'll assign 1 more terabyte. So it works on sizes of 1 terabyte. So if you go over 1 terabyte, you need 2 terabytes, and the next will be 3 terabytes, 4 terabytes. So the increments are on for 1 terabyte at a time. While compute, it depends on how many compute nodes you need. So potentially you'll need 1 during times that you don't need much compute power, but maybe overnight, when you need more compute power, you'll assign more compute nodes. So you will be able to grow independently or compute or storage. And you'll be able as well to pause compute. For example, let's say that we're running an environment where we have 4 compute nodes and we have the storage. Let's say that we don't need to run this 24/7. Let's say that during the weekend, we want to pause the service because all the reporting or it's not happening or it's happening in Power BI using import mode. So at that point of time, we can say that, you know what, we want to pause the compute. So we're going to be paying only for the storage. And now let's say that on Monday morning or Sunday in the evening, we want to start running we want to start loading the information again. So at that point of time, we'll start the compute and we'll be paying again for that compute. So this means that I always say the recommendation here is to use Azure Synapse Analytics only if you have many terabytes of data or more than 1 terabyte. My suggestion is that if you don't need to run your workload 24/7, definitely go and explore Azure Synapse Analytics. It works on, instead of using database units, we're going to be using data warehouse units. Again, this is a combination of CPU, memory, and IOPS. The whole reason for doing this is that because by creating this logical purchase model, in the future, you may have 500 data warehouse units, and maybe Microsoft assigns more resources in the backend. So it's a really good way to not for Microsoft to commit to a specific number of CPUs. You can have from 100 data warehouse units to 30,000 data warehouse units. So publicly available without getting support involved, you can create up to, I think, data warehouse 6,000 units. If you want to go beyond that, you need to open a ticket with Microsoft support to get those resources. With the release of the version 2, the generation 2 of the service also, you get around 1 compute node within each 5 data warehouse units, the high level. So why will you choose Azure Synapse Analytics and not Azure SQL DB? The first one, so this is not an application database. So this is built for performing data analytic workloads. So where you have a large volume of information, or you're looking for the information to be loaded really fast. Then it is an analytics database. You'll be pretty much looking at integrating data from many systems within a single database, which this means pretty much is that we're looking at building a data mart, a big data mart, or a data warehouse, or a really big analytics database. Size is something I mentioned. So I've seen, and it's a fair thumb rule. So if you're not working with more than 500 gigabytes of data or more than 1 terabyte of information, maybe Azure Synapse Analytics is not the best product for you. But the point here is that you need to remember the question that we highlighted at the beginning. Maybe your database right now is 500 gigabytes. So how big is your database going to be in 1 year or 3 years or 5 years? When you build a data warehouse, the whole idea is to not only to keep and bring more data, it's also to integrate data assets from different systems. So bring more data sources as well as more data assets. So from a strategy point of view, definitely recommend to take into account Synapse Analytics. And the other point is that if you don't need a relational database within your data warehouse that is running 24/7, let's say that we need this database only 10 hours a day. Let's say that we need, let's go a little bit. Let's say that we need this database 12 hours a day. So we use 3 hours a day to load the data within the data warehouse, and we'll make it available during the business hours. So by reducing the number of hours that the service needs to be available, the ongoing cost within Azure is going to decrease heavily. It comes down with some Transact SQL restrictions. So this means that potentially if you're running a SQL Server database, you'll need to refactor the code to be compliant with Azure Synapse Analytics. That's something that you really want to do because also the engine is different. So you want to take advantage of that engine, and you need to refactor some of that code and tables. And then there's a serverless option coming up. So this serverless option is going to allow you to, as well, to pay only per execution time of your queries, which is great. There is a really good decision tree available in this web page, pretty much built by written by Blue Granite. It's really good. So the decision tree, I'll say that it's still valid. Besides that, it's a little bit old. I do suggest to go and have a look at it. Because the retention period as well for the backup retention period goes only up to 7 days if you're doing DR, for example. Within the new experience in Azure Synapse Analytics, the new Azure Synapse Analytics, there's a new workspace experience that is called or named to be the one-stop shop for analytics. That means that if you're performing any type of data analytics workload, you're going to be able to do it in Azure Synapse Analytics. If you are working with big data or data warehousing, the new experience of Azure Synapse Analytics will be the place to go. You'll have from the previously seen, we've previously seen the Azure Synapse, the SQL pool, only the database engine. So you have that available in a on-demand option, serverless option, as well as pre-allocated resources. You'll be able to use as well Apache Spark within the workspace experience. You'll be able to have you're going to be able to have all your data analytics ecosystem within Azure Synapse Analytics workspace experience. So let's go and have a look at that. So I understand the difference. So first of all, I'm back in the Azure portal. So if I type here Azure Synapse Analytics, you see three links with a name. The third one actually is the one that we covered today. This is only the database. That's the SQL pool. The workspace experience, it was yet to be generally available. It's public preview. You can go and create this workspace experience, and this is going to be the one-stop shop for analytics. So if I click here, and the third one is just a link between different services, not important for this session. So if I go for the workspace experience, this comes with its own web portal that pretty much we have here. So this is going to take you to a whole new world. So you'll be able to do Power BI, Data Factory, notebooks, big data or data warehousing development within this workspace experience. For today's session that we're talking about relational databases, we're going to jump directly within the manage option first, because within the SQL pools is where I'm saying you'll be able to create pre-allocated resources. You pretty much you'll be able to say, okay, I need an Azure SQL Synapse Analytics with only little data warehouse units, only one data warehouse, 100 data warehouse units. You need more, you look at more, you'll be able to scale up and down, scale out and scale back. And then this will be the provisioned Synapse SQL pool, but then it also comes with a serverless option by default. This means that you only pay for the time that you execute your queries, the time that how much data you're reading actually within the serverless option. And if I go to my data hub over here, you see that we have here choose serverless option. This is Synapse Analytics using a serverless option. Pay only for the data that you read. And the whole point about this is that if you like to, for example, to go and explore your data lake from here, I'll go to my data lake. Let's drill down at the folders within my data lake. I'll change, let's go with Parquet 5 because they are highly compressed and is the recommended format file for data analytic workloads. So from here, I can easily click and return, explore this file from here. What's important for here, what I want you to see only is that this is going to read information from a file connecting to a serverless option using my database that is called serverless. So when I'm running this query, I'm reading the file and I'm paying only for the data size that I read. So that's what I want to highlight, that this is in the backend, Azure Synapse Analytics, and still a relational database. So before we move forward, I wanted just to take a step back. You can see that the report for the Azure SQL Managed Instance finished, and pretty much there are not any problems, and will be good to migrate these databases to Azure SQL Managed Instance. So to summarize Synapse Analytics, allow you to think about two different things. First of all, you have the SQL pool, the data database engine, the relational database that we have been talking about today. And then you have this new workspace experience that potentially will be generally available anytime soon. And you'll be able to do all your big data and data warehouse workloads in a single portal and using a unique experience, a collaboration portal as well. Summarize as well the difference between Synapse Analytics and Azure SQL DB. Pretty much remember the engine. Today we covered symmetric multiprocessor system and massively parallel processing systems. So pretty much the engines are different. So if you're going to use a Synapse Analytics or Azure SQL DB, you just need to take advantage of that engine differently. So you need to plan and develop skills that maybe we didn't have before while working with SQL Server. Then Synapse Analytics, definitely, if you are using it for, it'll be used for data analytics workloads, and Azure SQL DB will be used for small data analytics workloads, but also for highly transactional applications. And finally, we'll wrap up the session of SQL Server Engine, and we need to talk a little bit about the open source offering within Azure SQL DB. So within Azure SQL DB, within Azure, you're able to spin up a managed database using MariaDB, Postgre, SQL, or MySQL. Why is this important? So, because first of all, these databases are still using the platform as a service cloud model. This means that Microsoft is going to look at everything for you. but the application and the data. So Microsoft is going to manage hardware, storage, and networking for you. So you don't need to be worried about those things, which is amazing to say that about when you're talking about these open source databases. The second key thing is that it is not only a managed database, it's that you're going to get 4 nines. So 99.99 of availability throughout the year. The 3 of them, they are still using the symmetric multiprocessor system. In the case of PostgreSQL, there is a hyperscale option that works a little bit different from this. It's more closely related to the architecture of a compute nodes and control nodes, but the common offering pretty much using the symmetric multiprocessor system. The vCores option, what you're going to find actually is that the pricing, it is quite similar. I'll put it this way, they're more cost effective than Azure SQL DB, because you don't need to pay for the add-on that is the license of using the SQL Server Enterprise features within Azure SQL DB. But anyhow, if you're looking at migrating an existing on-premises MariaDB or MySQL to Azure, you can still keep running the same SQL Server open source engine while taking advantage of a managed instance. Here you have the versions that are supported in the 3 of them, in PostgreSQL, MariaDB, or MySQL. You get the 4 nines, seamless migration. There is as we've seen before, that we have the data migration assistant. There are other Microsoft free client tools that you can easily use to migrate your MySQL from on-prem to Azure. It gives you an assessment. It allows you to migrate the data as well. And it comes with all the amazing features. So all the information is going to be secured. It's going to be secured in the Azure data center and encrypted at rest. You have all the advantage of defining the backups that you want to use. So all enterprise features built on top of open source SQL Server, open source database engines. And I like to, I'm cautious about time, so I'd like to keep a few times for questions. Do you have any questions in the chat, Warwick?
We do. So with the Azure SQL PaaS offering, what options are there for connecting Power BI, Excel, SSRS, and other query and reporting tools in terms of handling connections and credentials?
Good point, actually. That's an excellent question. So in Power BI, you have connectors pretty much for all of them. So you have connectors for Azure SQL DB, SQL Managed Instance, Synapse Analytics, MySQL, MariaDB, Postgre. What you need to look at regarding credentials, so that's a good point. So some of them, they are going to be fully integrated with Active Directory. So you'll be able to use even multi-factor authentication. Some of the other ones, like the open source ones, they have maybe more limitations, and you'll end up working, for example, with a specific user and password. Then within connectivity, so it'll come down to network configuration. You just need to keep in mind that some of them may require to open some firewall rules to allow Power BI to connect to those databases. But definitely you'll be able to work with Power BI with all the relational databases that we've seen today.
Okay, thank you. If we have an application that was developed for an IaaS instance of SQL Server, whether that be in cloud or on premises, can we put that into a serverless environment with no code changes for us to be able to evaluate a serverless environment on our application?
So can you repeat the question?
So
Please,
if we have an application that was
yep.
built and created to run in an IaaS environment, whether that be cloud
yep.
or on premises, are we able to drop that application database into a serverless environment without any code-based changes, allowing us to evaluate the serverless environment?
Yep. So you'll definitely be able to do that. Only you are using a specific custom libraries that may not be available within the Azure SQL Database serverless option. So that'll be the only takeaway. So make sure that maybe if you're using any custom libraries within the store products within that database, they may not be available in the serverless option within Azure SQL DB. They will definitely highly suggest to explore the serverless option within Azure SQL DB. It comes with a cost. So you'll pay only for execution time of your queries, but that execution time it'll be greater. Let's say it'll be greater than if you're running a vCourse pre-provisioned option.
Okay, so just to summarize, if you're using the serverless, the price that you will pay is that the performance under the serverless, the execution time, I should say, of the query in serverless is going to be longer than if you were running a pre-provisioned environment that has appropriate resources given to it. Is that what you're saying?
Yeah, yes, part of it and no. I'll summarize. So yes, you can move your application database. You can try to move your application database to a serverless option. That wouldn't be a challenge unless you are using some custom libraries that are not available for use in the serverless option. Maybe we'll leave pricing outside the question. Pricing will work different. Come down to how long you are using it. Maybe you can. I do suggest, for example, script out the schema of your existing database and go and try to deploy that in a serverless option in Azure SQL DB.
All right, no problems. Now, if we were running a managed instance, does that get server level patches and SQL patches applied with no downtime?
That's a tricky question. I mean, downtimes, right? So I think you'll get you have some ownership on how frequent and the time windows where you want Microsoft to apply those patches, and you have maintenance windows. From what I've seen, you may run into some downtimes in the sense of loss of connectivity sometimes, but that applies to all the databases that we've seen before. So you've seen that those 4 nines that we talked about. So we talk about 4 nines of availability throughout the year. That means that maybe the database is not available during 1 hour. So what you need to think about as well is that hour maybe is split across seconds, across multiple days, where they're running some sort of maintenance in the backend in the Azure data center. So I'll say that sometimes you lose the connectivity of your application.
Okay. Staying with managed instances, do managed instances include reporting services?
Good question. No. So there is not an offering, a platform as a service offering for reporting services. They're able to spin up a VM. The report server database host that in an Azure SQL managed instance, but it doesn't come with all the web service that you need to configure and have running in a VM or a premises server.
Okay. And our final question that we have, if we are running a database in an elastic pool, is there a way that we can take a backup of that database for protection purposes? But the main purpose of this question is there an easy way for us to take a database offline in an elastic pool and have the ability to easily bring it back up online down the track, for example?
That's a good question. I'll say that there is not a built-in feature that you can use, so you need to build your own PowerShell features to backup and restore that database on the backpack, for example, using PowerShell scripts. There is no built-in feature, so you need to develop the solution yourself.
Okay, no problems. Well, if there aren't any further questions from the attendees, I'd like to thank David for giving up his time and coming along to our session this month and talking to us about relational databases in Azure. I'd like to thank everybody for being part of this month's session. If you haven't already registered, and you may not be aware, but Pass Summit did start today with its pre-cons. There are further pre-cons tomorrow, and then there is the rest of the week with all of the sessions. There is still time for you to register and get your access to the Pass Summit and join those regular sessions. With that, everybody stay safe, and I look forward to seeing you all online for our next session.
Thanks, everybody. Thanks, Warwick, for organizing this virtual chapter and for your contribution to the community. Take care.
Thanks, everybody. Bye.